Do you know how to solve trigonometric equations? Hi, welcome back. In this video, we'll learn how to solve trig equations, and I will solve two examples for you. At the end of the video, I'll give you two problems to try on your own. Now, with no further ado, let's get to work. In the first example, we have 3 cotangent to square root of x plus 5 cotangent of x plus 2 equals 0, where x is between 0 and 2 pi inclusively. The first step is to identify the non-permissible values. We know that cotangent of x equals cosine of x over sine of x. We don't want to have a 0 in the denominator, therefore sine of x cannot equal 0, which means x cannot equal 0, pi, or 2 pi. To figure out why this is like that, 0 pi and 2 pi must be excluded. The reason is at these angles, in the beginning 0, then pi, then 2 pi, at these three angles, sine of x is 0. So these are the three non-permissible values. Now let's get back to the equation and solve it. This looks like a quadratic in disguise. The reason is if I replace cotangent of x with a new unknown variable, then I'm going to have 3a squared plus 5a plus 2 equals 0. Now this is obviously quadratic. This is called substitution for simplification. We substituted cotangent of x with a to simplify the equation, and now you can see that this is a quadratic. Now I can factor this quadratic into 3a plus 2 times a plus 1 equals 0. This will give me two answers. The first one, a equals -1. The second one, a equals -2/3. And from the first one, I can say that cotangent of x is -1. From the second one, cotangent of x equals -2/3. Now let's go and solve each of these two equations. The first one, cotangent of x equals -1, that's the easier one. Because we know there is a special angle of pi over 4 where cotangent is equal to 1. So the special angle gives me the reference angle, that's pi over 4, but we know that cotangent is negative in the second and fourth quadrant. The reason is in the first quadrant and third quadrant the slope are positive, but in the second and fourth quadrants the slope of the terminal arm is negative. Therefore, tangent and cotangent are going to be negative in the second and fourth quadrants. And now that I know the reference angle of pi over 4, and you know the reference angle is the acute positive angle between the terminal arm and the x-axis. So this is going to be pi over 4. The principal angle, which is from the initial arm, which is fixed on the x-axis, to the terminal arm, that's going to be pi minus pi over 4. So one of the answers, I'm going to name it x1, that's going to be pi minus pi over 4. The next answer is in the fourth quadrant. I'm going to name it x2, and that's again have the same reference angle with the x-axis, and that's here pi over 4. So to find the principal angle all the way from the initial arm all the way to the terminal arm, I need to subtract pi over 4 from 2 pi. So x1 is 3 pi over 4 and x2 is 7 pi over 4. And none of them is among the non-permissible values, so we have two valid solutions so far. Now let's move on to the next equation, which is cotangent of x equals -2/3. There is no special angle on the unit circle where the cotangent is 2/3 or -2/3. So for this case, I have no choice other than using a calculator. And to use a calculator, here's how I do it. I enter cotangent inverse of 2/3. So I use a positive value. The cotangent inverse of 2/3. This will give me the reference angle. And then with the same strategy that I used in the first part, in cotangent x equals -1, where the terminal arm must be in the second and fourth quadrants, With the same strategy, I will use the reference angle to find the two principal angles. So the cotangent inverse of 2/3 using the calculator will be 0.983 rounded to 3 decimal places. Now one of the angles, I'm going to use the same numbering, and I'm going to use it with x3. That's going to be the angle in the second quadrant, which is going to be pi minus the reference angle. And if I use 3.14 for pi, then the answer is going to be 2.159 rounded to 3 decimal places. The next angle, x4, that's going to be in the fourth quadrant. The terminal arm is in the fourth quadrant. So 2 pi minus 0.983, again using pi equals 3.14. The answer is approximately 5.300 rounded to 3 decimal places. X3 also I need to use the approximation sign because we approximated it to 3 decimal places. Now let's move on to the second example, where we have 2 cosine of x equals cosine of 2x plus 2 times sine of x, and x must be between negative pi and pi. And since there's no denominator, there's no non-permissible values, except that x must be between negative pi and pi. Since we have a mix of sine and cosine terms, like cosine of x, cosine of 2x, and sine of x, we need to make some changes to make this equation more manageable. And I'm going to use double angle identity, where cosine of 2x equals cosine of 2x minus sine squared of x. So I'm going to replace cosine of 2x with this expression. Also, I would like to move this term to the left side of the equation. So we're going to have 2 cosine of x minus 2 sine of x equals cosine squared of x minus sine squared of x. Now, if you look closely on the right hand side, we have cosine squared minus sine squared. It's like a squared minus b squared, which is the difference of squares, and I can use that to factor the right hand side of the equation. Also on the left hand side, I can factor 2 from 2 cosine and 2 sine. Therefore, we're going to have this new equation. 2 times cosine minus sine equals cosine minus sine times cosine plus sine. Now in this stage, lots of students are tempted to cancel cosine x minus sine x from the two sides, which kind of makes sense because they are the same factors and two sides of the equation are factorized. So why not? Why don't cancel these two? Here's the thing. If you cancel this common factor, you're going to miss a set of answers. So do not cancel common factors. Instead of that, bring everything to one side of the equation. And in this case, I would like to bring everything to the left-hand side. And then afterwards, we will factor this common factor. So let's do it step by step. Bring everything to one side. We're going to have this equation, 2 times this common factor minus the same common factor times cosine plus sine equals 0. Now that we have everything in one side and there is a common factor between these two terms, we can factor out this common factor. And with that, we're going to have cosine of x minus sine of x times 2 minus cosine plus sine equals 0. Now to solve the equation, we can set each of these factors equal to 0 and solve each of these factors. And with that, I mean, we set this guy equal to 0. That gives me one set of solutions. And then set this one equal to 0. That gives me another possible set of solutions. With the first one, cosine of x minus sine of x equals 0, we can see that cosine equals sine of x. And if we try the unit circle again, we can see that this happens at the reference angle pi over 4, and it happens in the first quadrant and third quadrant. And since we're working with the angles between negative pi and pi, we can start from negative pi, go around all the way around to positive pi. The first angle is going to be negative 3 pi over 4. So let's name that x1 equals negative 3 pi over 4. The next angle in the first quadrant, that's going to be pi over 4. Now let's move on to the second term, second factor, which is 2 minus cosine of x plus sine of x equals 0. This means cosine of x plus sine of x equals 2. And we know the maximum possible value for sine and cosine is 1. So both of them must equal 1. This means cosine of x equals 1 and sine of x equals 1. But as you know, there is no such angle where cosine and sine, both of them, can be 1. Because if you think about it, when cosine is 1 on the same unit circle, then sine is 0. So they can't be 1 at the same time. The other angle, when sine is 1 at pi over 2, then cosine is 0. So when one is 1, the other one is 0. We can't have both equal 1. So this equation don't give me any answer. No solution for the second one. But in the first equation, we got two valid answers, and both of them are within negative pi and positive pi. Now it's your turn. I have two equations for you to try on your own. The first one, 2 tangent the square root of x minus tan of x minus 1 equals 0, and x must be between 0 and 2 pi. To solve this question, you can refer to the first example that I solved. The second question, 2 cosine of x plus 2 sine of x equals cosine of 2x, where x is between negative pi and pi. And for this one, you can refer to the second example that I solved. Solve these two questions and leave your answers in the comment section. That's it for today's video on solving trigonometric equations. I hope you enjoyed it. And don't forget to leave your answers to the last two questions in the comment section. If you enjoyed this video, please give it a thumbs up and subscribe for more math contents. Until the next video, keep solving those math problems.